you. Good evening, ladies and gentlemen. My name is Sai, and I'll be talking to you about the future of women in engineering. So I'm quickly going to take you through my background, the challenges we face, some positive reinforcement. What is the future of women in engineering? What are the current developments? What are the future developments? And what women programs are available for support as well as the way forward? In terms of background, I am an electrical and electronic engineer. I am married with 2 kids. And the reason I'm saying this is a lot of times, especially women, feel that they cannot have a career if they are married, and they cannot have a life beyond having kids. And one of the things I want to emphasize is that I did my government certificate of competency actually during my maternity leave. So there's nothing that really stops us. We just need to move on. I actually studied in a rural school, so it doesn't matter where you study, and I guess a lot of you are actually privileged in terms of the schools that you go to currently. I did my engineering studies in India, so I was kind of uprooted from South Africa back to India. In those times, there used to be a lot of riots in the universities. And then I came back to South Africa to become an engineer in training, which obviously takes quite some time. And then you have to register as a professional engineer with the Engineering Council of South Africa. And I started doing some voluntary work once I became a professional engineer. So we accredit most of the programs in all the universities in South Africa. And I then joined the Association of Municipal Electricity Utilities, which is basically all the municipalities belong to, and was quite instrumental in changing the constitution to allow more ladies into executive as well. I'm currently involved with the South African Institute of Electrical Engineers, where I'm also encouraging women to partake more in terms of being in the engineering space. And what I want to say is that you don't stop learning. You have to have continued professional development. And while I got to my old age, I call it old age, I started doing my master's and completed my master's as well. So what I'm trying to show you women in particular is nothing actually could stop you in terms of what you do. In terms of the challenges, I always say that we can't focus on the challenges. We all have challenges, especially women in an engineering environment. However, I'm going to mention a few, but my advice is just move on. It's almost, challenges are almost like your past. Go beyond it. So whether you're in university or whether you're in a working environment, it's very male dominated. You often have the self-doubt about yourself, and you don't have time to network because you got to still cook supper, you got to take care of the husband. However, it's one of the most important things is to network with your peers as well. You have a lack of time to self-develop yourself, and you kind of, with your doubt, you have very little self-confidence as well, or self-worth. And one of the things that I learned very late in life was to take care of my health. It's until I had a wake-up call that I realized as women, that's the last priority that we have. We don't take care of ourselves. And especially in the engineering environment, we don't have a financial module. So this is something we learned the hard way once we're in the real world, is that we have to understand finances. And it's something I think we need to introduce in the engineering modules as well. And the digital world, the reason I'm saying is it's a challenge is a lot of young kids today, it's TikTok, Instagram, and it's kind of a distraction. Although going forward, I think it's something that you can learn from as well. I want to focus more on positive reinforcement as women in this particular arena. So you are vulnerable. We all have them, just embrace them. And a lot of times, especially women, we love to talk and we love to complain. I'm saying stop doing that and start listening. And it's all about attitude. So a lot of times we try to compensate our insecurities with like a chip on your shoulder. But how you treat others is part of your growth. And the most important thing for me is building relationships and networks. These are your building blocks. And I want to reinforce this because wherever I have been and wherever I've grown, it's due to these relationships and networks. And procrastination, my MBA was a procrastination in terms of should I do it, shouldn't I do it? So a lot of times, even in our work environment, we tend to procrastinate. And I feel that goals are dreams with deadlines. You have to say you need to do this by then and get to it. And currently, I mean, the revolution of the digital world, and I'm going to talk about it a bit more later, is actually taking over in terms of the way that the future actually holds. When I say study languages, I'm not just talking about English, French, and Mandarin. I'm talking about programming languages as well. And then no matter which environment you are in, or university or wherever, you're going to come across hard choices to make, difficult circumstances, unpleasant work environments, but never give up. And every time you always say you don't have enough time, there is time to exercise, there is time to be creative, there is time for everything if you start prioritizing your life. And you're going to advance in life by what you're going to learn. You're the master of your destiny. So embark on a self-discovery and be confident in what you are doing. Definitely what's important, don't stop studying. Continue with your professional development, which is also a requirement in terms of the Engineering Council. So the whole talk is the future women in engineering. So my question is, do women have a future in engineering? And my answer is a definite yes. There is not a single discipline of engineering that does not have women involved in it. Yes, we might be a minority, but definitely we do have a say in every single sphere of engineering. So it is a long process. It is hard work. As a graduate engineer, it takes you between 4 to 5 years. As an engineer in training, it takes you 3 years. Once you're a professional engineer, you need to develop yourself. It takes you years of developing yourself. There are formal ways of mentoring. So when you're an engineer in training, it's a formal mentoring process, but there's a lot of informal mentoring. And I think this is also crucial to you because you need to have a mentor to help you and to assist you as well. And you need to be in touch with what are the current developments in the engineering world. So a lot of the universities have traditional courses or engineering degrees, and I'm going to touch on some of the different ways that we can actually evolve and the diversities we have now currently with engineering. So I'm going to touch also on the future development. So if you have an interest area in one of the ones that I'm touching, and it's very few, there's millions of these that I'm going to touch on, then definitely go into those areas and try and study about them. So what are the current developments? Obviously, we're currently in the 4th industrial revolution. Everything is about Internet of Things. We hear about big data. Wearable internet. I think everyone's wearing a watch that can tell you your steps, your blood pressure, your heartbeat, your messages. It's part of everything. 3D printing. There's lots of smart systems, smart homes, smart cities, and fiberglass and cables are carrying a lot of information currently. And I'm just showing you here is a solar cell. So this solar glass is coated with material known as phosphorus, which can absorb ultra radiation and convert it to visible light. So the visible light is let through whilst the ultraviolet and infrared rays are redirected to a small solar panel on the side of the glass. And this technology has given rise to a lot of high rise buildings, which are converted using solar panels as shown here. Another example in terms of developments is drones. One of the applications is the ZIPLINE. It's a company from the US, which is quite prominent in Rwanda and Tanzania. And what they've done is they've actually developed a drone delivery system that delivers critical life-saving products such as vaccines and blood. And this drone is launched using a rail and a pulley and an electric motor to achieve about 100 kilometers per hour in 0.3 seconds. You can see the engineering in me is coming out now, hey? So this is another drone application, which is basically a solar powered plane, and it flies at high altitude, mainly in the stratosphere, and it is used for surveillance and intelligence in a lot of countries. And drones are also used in weaponry, which is used in the defense. So some of these drones can be, I think a lot of people might have seen this video where you can actually load them with explosives and target certain targets, whether definitely bad targets. So hopefully there are regulations in order to make sure that these are used for the right things. So what does the future hold? And I'm just going to touch briefly on the 5th Industrial Revolution. I did an entire talk on this for the SAIEE in terms of what it can hold and that it will happen very soon because we're evolving so fast in terms of technology. Machine learning, what is that all about? And robotics. Data explosion, nanotechnologies, quantum computing, artificial intelligence, humanoids, and supercomputers. So these are just a few that I feel might be of interest to you guys. And I'm just going to touch very briefly on it to let you know what it is all about. So in terms of artificial intelligence, it brings together researchers from cognitive science, neuroscience, as well as computer science. And by 2021, it's predicted that robotics and automation will take over, Bill Gates predicts that we're going to have smooth talking AI assistants trained to create conversations and not just obey commands. We're also going to have by 2022 robot dexterity. So in other words, the robots can anticipate your human needs. The global robotics market is predicted to reach close to $500 billion by 2025, which is huge. In terms of agriculture, there's a huge expansion with regard to drones and robots, and it's predicted by 2028, we'll have about $23 billion invested in this. By 2023, we should have supercomputers in our pockets, and by 2030, we would have computers being more intelligent than humans. And I'm sure people saw the tweets coming from Elon with regard to this, that he's quite worried about this. And machine learning is going to be quite common. So the joke is that humans are hooked on Instagram and TikTok, and we all just checking out our phones while the machines are busy learning. So in terms of data explosion, and I'm going to be very brief and not go into detail with any of these, but it's just to spark an interest in you guys. So data explosion basically is large amounts of and volumes of data and storage that have actually created this data explosion. And the reason for that is basically the Internet of Things, which is like sensors. So the prediction is that by 2025, we would have created over 90 zettabytes of data just from IoT devices. And these are mainly in cameras, etc. And by 2035, we would have close to 500 billion sensors globally. And that is huge. So AIs and machine learning are important to tackle this data explosion. How are we going to actually understand what this data is doing to us if we don't have AI and ML? And the zettabyte era is basically between 2012 and 2016, our digital data exceeded 1 zettabyte. And if you want to understand what is a zettabyte in terms of terabyte hard drives, you are looking at 500 million of them filling 2 terabyte hard drives at a current cost of 575 billion rand. So this is huge. In terms of nanotechnology, so what is nanotechnology? It's the science of manipulation of materials at atomic, molecular, and macromolecular scales. So for you to understand what is the size of a nanometer, we've all heard of COVID-19 virus being tiny, and it's basically about 89 nanometers. So if you take the width of your hair, you could fit in 750 COVID-19 viruses. That's what a nanometer is in simple terms. So silver, these are used to color pigments in stained glass and ceramics. What are the applications of nanotechnology? They're used as polymers in chemical processes, computer chips, DVD drives, enhanced data storage, nano-engineered membranes. And another one is used for self-cleaning windows, where they use a 15 nanometer thick activated titanium oxide, which is engineered to be highly water repellent. So when the rainfall actually falls on the surface, it just washes away the dirt. And it's also used in sunscreens, where it is used to reflect and absorb ultraviolet rays. Quantum computing is a topic on its own. So very briefly, it's all linked to conjugate coding. It was discovered by Stephen Weisner in 1960. So it was also linked to the Holivo theory, which has to do with n qubits. And this is basically, IBM has built a qubit quantum computer. And the speed of quantum computers is measured in petaflops. So although quantum cryptography is in its infancy, a worldwide quantum cryptographic network is achievable in the near future. So what's artificial intelligence and what's going on with that? So if you look at all the Tesla cars currently, they're built with hardware that's required for self-drive, which includes 8 vision cameras, 12 ultrasonic sensors, radars to be used by full self-driving computers. And data and computing are already having a major impact on disciplines like humanities, machine learning, and artificial intelligence. And MIT has already announced a $1 billion plan to create a new college just for AI. And the UK has already set aside billions to develop manufacturing, because they feel that this is where the world is going to. So in terms of humanoids, I'm touching on a few very well-known ones. Sophia, she's been granted Saudi citizenship. You have avatars like the Neon, you've got Atlas, You've got Ocean One, Neo, Petman, and Pepper. And sorry, if you can just go back, if you can actually go and check some of these videos, they're totally amazing. I mean, it blows you away basically. So another cobot is a bionic arm. And this arm has 7 degrees of freedom and allows customers to customize what they require. It is currently being used as a replacement for a human arm. Another example is Mercedes-Benz hologram exterior, where it's a concept car that uses photographic technique that records how light is scattered from an object, thus giving an option to customize the exterior. So you can choose any color you want, how it should look, the interior, and specific functions of the car. What is quite interesting is actually this bionic fins here. There's 33 of them, and I think they can be used to gather the speed, communicate with the driver. So it'll be quite interesting to see how they use these bionic flaps actually. And what is important here is you also have veg bots and apple robots. So previously, to pick something very delicate like an apple or lettuce was quite delicate. And we've now got robots that can actually do this. In terms of supercomputers, they're used for scientific and engineering applications dealing with large databases. It's a large amount of computation. So with the current COVID crisis, it was quite important to actually use these supercomputers to analyze the data. And NASA and IBM have got some of the best supercomputers, and they have actually lent a hand in terms of trying to have frameworks and computational studies to actually stop this virus. So they're using the supercomputers, and I spoke about that. So how are they actually doing this? So basically, there is a spike protein, which is called the S protein, which actually merges with our cells and causes the infection. So in order to develop a vaccine, we have to find a compound that can actually bind with this S protein and make it ineffective. So what is happening is a lot of information in terms of drug components that can bind are being modeled. And you're looking at close to 8,000 compounds. And so far, they've identified 77 possible ones that they could actually use, which would be a possible treatment for the COVID-19. So we're using currently these technologies. So getting towards the end is we have a lot of women programs in South Africa that can assist women in engineering. And specifically, we've got South African Institute of Electrical Engineers, Women in Engineering. We've got the AMU, Women in Engineering. When you get to university, there's student chapters that you can join that will also assist you. We've got the IEEE, Women in Engineering. We've got the WIFIO, Women in Engineering. We've got Women in Oil and Energy South Africa, STEM programs, Women Advancement, and Women Mentorship. So you can see, if you go into engineering, you have a lot of support that will assist you as well in terms of all this. So in conclusion, what is the way forward? From the limited examples that I've shown you, there is a huge amount of diverse opportunities out there. And you could diversify from the traditional engineering. I mean, I showed you, I was just an electrical and electronic engineer. Now, I think you start off with robotics and artificial intelligence. And I think one of the professors, Benjamin, is also going to be talking about that. It's totally diverse currently. There's so many areas of specialization, and you can continue to develop yourself professionally as well. Hard work and perseverance are important for your success. One often leaves out networking amongst your peers, but it is very important that you do actually a lot of networking. Believe in yourself and your dreams, and women in engineering is a positive force. So in conclusion, I would definitely encourage the participation of women students in engineering. And let me leave you with a quote from Steve Jobs. Your time is limited. Don't waste it living someone else's life. Don't be trapped living with others' people's thinking. Don't let the noise of others' opinion drown your own inner voice. And most important, have the courage to follow your heart and intuition. They somehow already know what you truly want to become. Everything else is secondary. I thank you.